Normality of n factor is molarity, not the volume strength. Other center can also pose the answer, but the relation between volume strength and normality. Let's say the H2O2 normality is 5 normal, and you have to calculate the volume strength. So, what is the factor which is multiplied by normality, and you can able to directly get volume strength. First, you have to understand the definition of volume strength. 1 ml of H2 to produce how many ml of oxygen at SP? That is known as volume strength. नहीं हो रहा है? 5.6. 5.6 into normality is volume strength. Clear? Let's say this is H2O2 and the normality is N. The normality is N. N normality means an equivalent of H2O2 present in 1000 ml solution. We know that H2O2 gives H2O plus half O2. Okay? And we have to calculate 1 ml H2O2 gives how many ml oxygen. This is what we call volume strength, and especially at SPP. Okay? Can I say the normality is N? That means N equivalent of H2O2 is present in 1000 ml H2O2 solution. Yes? Reverse is also true, so that we can able to write that 1 ml H2O2 solution consists of N by 1000 equivalent H2O2. See the H2O2, the oxidation state is -1, -2, and 0. So the oxidation state of oxygen is changing, and it is a disproportionate reaction. -1 say -2, -1 say 0. When the reaction is disproportionate, we are not able to use the law of equivalent. So we have to convert this in the mole. So 1 ml H2O2 consists of N by 1000 equivalent of H2O2. Can I write 1 ml H2O2 solution consists of N by 2000 mole of H2O2? N factor of H2O2 is 2. So N by 2000 moles of H2O2. Okay. So 1 mole H2O2 gives half mole oxygen. That means N by 2000 mole H2O2 will give N by 4000 mole oxygen. Yes. N by 4000 multiplied by 2244 ml O2. 1 ml H2O2 solution will give N by 4000 into 2400 ml oxygen. If you divide this, you will get N into 5.6, which is volume strength. So you can even calculate the volume strength in terms of normality. Okay. So you can able to calculate the relation between molarity and volume strength. Yeah. Clear? Okay, this is the third type of oxide, which is known as suboxide. In the suboxide, the quantity of metal or element is higher. In general, the oxide which we have read so far is oxide, peroxide, superoxides, right? If I am saying that oxide, that means efficient oxygen. Peroxide means oxygen are higher. Okay, superoxide means oxygen is higher than peroxide. Suboxide means oxygen is less than normal oxides. Right? So oxide, number of oxygen are normal. Peroxide, oxygen is higher. Superoxides, oxygen is higher than peroxide. Suboxide, oxygen is less than normal oxygen. Say carbon monoxide, CO, one oxygen, one carbon. But if I make superoxide, there are three alene structure of oxygen. These CCCOO. Clear? So these type of oxides, the carbon content is very low. Clear? Yes. All pi bond are in plane or not in this structure? Plane. There is a structure similar to alene. Alene is optically active. 3 times they have already asked in the JEE mains. The hybridization of carbon is sp. This hybridization is sp. sp. Clear? What is the shape of sp? How is unhybridized orbital in there? 2. So this carbon is sp. Shape is linear to unhybridized orbital. Yes. Let's say one unhybridized orbital I have made like this in the plane. Yes. And the second unhybridized must be above and below the plane. So the red marker is above and below the plane. Simple. See, what is the hybridization of this carbon? Sp. So if this is also sp, this is again carbon, and it is linear. Yes. This is linear. One unhybridized is in the plane, and other unhybridized in the perfect above and below the plane. So there is a pi bond between this unhybridized. Okay, pi bond between this unhybridized. Now this is also sp. If I make unhybridized, now this pi bond can form bond with this. Yes. If this is also oxygen, this is also hybridized. है ना? तो अगर वो इसके साथ तो बना नहीं सकता, उसको तो प्लेन में आना पड़ेगा, नहीं है? तो ये वाला पाई बॉन्ड इसके साथ बनाएगा. That means all pi bonds are not in the same plane. All pi bonds are not in a same plane. Clear? So this is carbon suboxides. Clear? Nitrogen also forms this type of oxides. So first classification, we have learned about the type of oxides. They are simple oxide, then peroxide, superoxides, and suboxide. They are the nature with respect to oxygen. Now, oxides may be acidic, base, or neutral, or amphoteric. Based on basic oxide, we are learning first. Basic oxides. Basic oxides are those oxides which give OH minus in aqueous medium or which produces bases. Generally, all the element of alkali metal, like lithium, sodium, potassium, and earth metal, MgO, calcium oxide, right? These are basic oxides. Clear? Why they are basic oxide? If these metal oxide M2O is added in water, oxygen consists of 2 minus and it is strong conjugate base. So this O2 minus reacts with water to accept one hydrogen and it produces 2 OH minus. You will say that there is a metal which can form bond with this OH, MOH, but this MOH is 100% soluble in water. Okay, why this 100% soluble? Because the hydration energy of these metals are very high. Solubility of any hydroxide is defined by 2 factors. Okay, yeah. Solubility of any hydroxide is defined by 2 factors. One is hydration energy, other is lattice energy. If hydration energy is higher than lattice energy, that hydroxide will be soluble. So almost all alkali metals, hydroxides are soluble in water and the solubility increases down the group. Solubility increases down the group because lattice energy decreases. So highly basic in nature are cesium hydroxide. So we can say CSOH, then KOH, then NaOH, then LiOH. Clear? T2O3, Bi2O3, THO2. These oxides are also basic. Whereas CrO3, CO2, CO3, S4O6, these oxides are also basic. Not all oxides upon reaction with water and H plus give hydroxy, and some oxides are basic due to the reaction with the acids. If they react with HCl, HBr, they are treated as basic oxides. Clear? Now, three more oxides. One is amphoteric, acidic, and neutral. Amphoteric oxide, aluminium Al2O3. This is amphoteric oxide because it reacts with HCl as well as NaOH. See the reaction, the oxidation state remain constant. In Al2O3, the oxidation state of aluminum is +3. When it reacts with HCl, it gives +3. When NaOH, it will give +3. Because it is acid-base reaction. So, amphoteric oxide are the oxide which react with acid as well as base. Acidic oxide, almost all non-metal, mainly non-metal oxides are acidic oxide like B2O3. They generally give on hydrolysis acids. H3BO3. H3BO3 is acid. Why? दे ही नहीं पाए, कैसे देगा H3? रेजोनेंस थोड़ी ना ओम. If H3BO3 is acidic, then all the hydroxide of boron family must be acidic. It will give H+. The structure BOH like this. BOH, OH, OH. ये H+ कभी निकल सकता है? ये निकलेगा तो ये O- तो highly unstable है, नहीं है. This is acidic because when this H3BO3 is treated in water, the size of boron is very small and it is electropositive in nature. All oxygen withdraw electron from boron, right? So it is electropositive. So if it is electropositive, the polarization ability of B is very high. So this oxygen, as well as this is a Lewis acid. Lewis, it forms 6 electrons. This oxygen attack to this boron. Now this boron, this oxygen get positive charge, it accepts electron and give H+. So it will become H bore plus H+. So after reacting with water, it displays H+ from water. That's why it is acid in nature. But in the family, if you go down the group, the size of central atom increases, the polarization ability decreases. So when water attacks the central atom, the polarization ability decreases, it displays OH-, and they will become basic. So H3BO3 is, or B2O3 is acidic only because the size of boron is very small and the polarization is very high. It is able to generate H+. But if the size increases, it will displace OH-. Neutral, you always know that neutral are only 1 or 2 nitrogen and carbon. Okay? Here, these structure we have already completed. Selenium structure, sulfur. So let's start the compounds of oxygen family. Some of the compound chemical properties as well as physical property you have to learn. That oxygen, ozone, sulfur, H2S4, H2SO3, H2S gas, H2O2. These are the compound of oxygen family which you have to learn. All the reaction preparation property. Okay. First is oxygen. Preparation of oxygen. We have written thermal preparation. Okay. These are the 4 very basic preparation of oxygen. First one is HGO. See, mercury, the oxidation rate is +2 and oxygen is -2. It is self-reduced and converted to Hd and O2 is formed. So mercury oxide, from mercury oxide, preparation of oxygen is a very good method. Similarly, we have written all the oxides. See, upon thermal decomposition means we have heated these oxides. So preparation of oxygen. Oxygen is prepared only from the, or you can say good source from the oxides, because oxides are easily available. Mercury oxide is easily available, silver oxide is easily available, MnO2 is easily available. Upon acidic hydrolysis, they will produce certain other element. Thermal decomposition, they will produce metal as well as free oxygen. So this is the first method of preparing oxygen from metal oxide. Okay, this is simple thermal, or we are heating these oxides at elevated temperature to produce oxygen. This is the second method on which we are producing oxygen from the oxide, which consists of higher number of oxygen like KNO3. KNO3 when heated, it gives KNO2 plus O2. K2Cr2O7. When heated, it gives K2Cr O4, Cr2O3, and oxygen. Almost all. Why we have written rich salt? Because all consist of very huge amount of oxygen as compared to the last. Okay, so these are the good source of O2. KClO3, KCl plus oxygen. What is the factor of KClO3 in this reaction? Fourth reaction. KClO3 of KCl plus oxygen. The N factor of KClO3. This reaction what went? If you see the chlorine, this the oxidation state of chlorine is +5. नहीं है +5. 3 to 6, 1 +5. Oxidation chlorine is -1. So +5 to -1, chlorine accepting 6 electron, whereas oxygen -2 to 0, it lost 6 electron. So this is a reaction in which chlorine was gaining 6 electron and oxygen lost 6 electron. So gain 6, loss 6, so the N factor will be 6. If both gain 6 electron, N factor will be 12. Okay, so this is perfectly a redox reaction, self-redox reaction, in which chlorine accepts the electron and oxygen lose the electron. Okay. Second thing, that these are the method of preparation of oxygen when we are simply heating these oxides. Okay. Second is the reaction with H2SO4, and again these reactions are also take place in approximate temperature 140, 160 degrees. See, MnO2 itself give with H2SO4 give oxygen, MnSO4. In acidic medium, M always go +2 oxidation state, irrespective of the oxidation state which is present. If the acidic medium, it will undergo +2, from +4 to +2 and produce oxygen. Similarly, potassium permanganate again Mn +2. Okay, K2Cr2O7 acidic medium goes to +3 and give oxygen. So KMnO4, K2Cr2O7 are the good source of oxygen. So we can able to produce oxygen from permanganate and dichromate by treating H2SO4 with these molecules, right? Ozone. Reaction of ozone. Ozone can be prepared from oxygen. Ozone can be prepared from oxygen. See, oxygen gives ozone. Preparation of ozone from oxygen needs some ozonizer. Need some ozonizer. Let me ask you one question. Let's say this is the ozonizer. हमने यहाँ से oxygen दी, and this oxygen is 100 moles. 100 moles. Sorry, 1000 moles. And it gives oxygen and ozone. Mixture of oxygen and if mixture of oxygen and ozone and 888 mole, then what is the mole of ozone and oxygen? Clear? 1000 moles of oxygen is passed through ozonizer, and this oxygen is converted to oxygen and ozone. Mixture of oxygen and ozone are 888 moles. Then find number of moles of oxygen present in mixture. Calculate. अच्छा ऊपर से बताएंगे जल्दी छोड़ना क्लास अपनी बात कर समझ जाएगा I think it is 400 something. Oxygen is ozone is converted to oxygen. Yes, you balance the reaction, and we know that almost some oxygen left and some part of oxygen is converted to ozone. So let's say out of 1000 mole, X mole of oxygen is converted to ozone. Out of 1000, this total number of moles 1000. From 1000, X mole is converted to ozone. So the ozone form will be 3x by 2. Can I write 1000 minus x plus 3x by 2 equal to 888? We can get the value of x. दो तक है एक तो ऐसे कर लो दूसरा कंजर्वेशन ऑफ एटम यूज करो वी हैव एडेड 1000 n into 2 number of atoms तो मिक्सचर में 1000 n into 2 ऑक्सीजन कहेंगे this is 888 minus x n 888 minus x into 3n must be equal to 1000 n into 2 number of atom will be conserved बैलेंस कर ही लोगे ठीक है क्लियर बेटा